Okay. So from here, right, we wanted two numbers. Minus 8 is the product. And 2 is the sum. That's what we're looking for. But what numbers do that? Well, we have 4 and minus 2. The product is minus 8. 4 plus negative 2. That sum equals 2. Good. That's good. So 4 and minus 2, that's where this came from. So substituting, we get the factorization of this wonderful polynomial. We completely factored it. Good. So that was fun. Okay. Are there any questions about that? Okay. Well, this one's going to be a little different. Notice we do have a polynomial here. But notice, look at this factor. This is not x minus something or x or even x plus something. It's 5 times x plus something. You know, you can't just dive right into synthetic division, right? Even with the previous examples, we had x minus or plus something. I mean, here it was minus, but we have done other examples where it was x plus something. Basically, the leading coefficient was 1 of the divisor. Well, that's not the case here. What do we do? Well, we'll do this. If you think about what we're actually doing by dividing, this is actually what we're doing. We're taking the polynomial and dividing it by we're dividing it by another one. So we want to know what's happening here. That is, we want to know what the quotient and remainder are. I mean, in this case, we're trying to see if this is a factor. We're really trying to see what is the remainder of this. Now, it looks kind of nasty, doesn't it? You might be thinking, well, we can't do synthetic division. But wait, yes, we can. Because of this. Notice if I take 5x plus 3 and multiply it by a fifth, I do the same thing to the top. You know, you want to keep everything algebraically the same, equivalent that is. If I do that, and then I distribute the 1/5, well, this 5x becomes x. This 3 becomes 3 over 5. Actually, you know what? Let me just write that out. So if I distribute, I have 5 times this x over 5. I didn't type it out, but I probably should have. So that's why I wrote it here. Okay. But you can see there's going to be cancellation, right? The denominator becomes this. But we have to handle the numerator as well, and that's what I'm doing here. So you want to keep it in balance, so to say. Right? So we have a fifth, and we're distributing. So we get this polynomial, right? 25 over 5 is 5. 150 over 5 is 30. 131 over 5, I'm not sure what that is, so I left it as a fraction. 30 over 5 is 6. In other words, what we did was we converted this into calculating this quotient, the quotient and remainder of this. That is, we're dividing this new polynomial. I'm calling it g of x. So g and f are usually what we use for functions, and that's what we're doing here. I just called it g of x. But we're dividing it by this. We can use synthetic division. We can. If 5x plus 3, I divided the polynomial and this by 5 to get this. That's essentially what I did. And now we're going to use synthetic division. Let me just say it again. Basically, what I did was the polynomial, we're dividing it by this. We divided it by 5. I do write out the procedure later in the slides, But that's really what happened here. I mean, yeah, I multiplied by a fifth. That's the same thing as dividing by 5. Now we can do synthetic division. And that's what I'm doing in the next slide. This was the new polynomial we got. I'm dividing it by x plus 3/5. Remember, it's plus. For synthetic, it has to be minus. No worries. I just write it as minus a negative. And that's what I'm doing here. Even though we have fractions here, the process is still the same. So this number 5 comes down. You have minus 3 over 5 times 5. If you do that product, though, the 5's cancel and you get minus 3. Then we add, get 27. We have minus 3 over 5 times 27, and that becomes minus 81 over 5. We add, as you can see. When you add or subtract, remember, the denominator stays the same. Fractions. So in this case, we have 131 over 5 minus 81 over 5. That's actually 50 over 5, which is just 10. And then we multiply again. We get negative 30 over 5, which is negative 6. 6 plus negative 6 is 0. And so the process is basically the same after we divide by 5. Or multiply by a fifth, same thing. So in other words, these numbers will be the coefficients of the quotient. And this is the remainder. So our quotient is 5. Remember, it's 1 degree less than your dividend, which is this. So it's going to be degree 2. So it's 5x squared plus 27x plus 10. Our remainder is 0. Okay, well, let's handle our answer. I wrote this. This was from the division algorithm. Okay? This is what the quotient and remainder do. Where they go. This was our dividend. I mean, in this case, it was G, but capital F is taking the role. G is taking the role of that. So this is our dividend. This is our divisor. We get our quotient plus our remainder over D. 0 over any non-zero thing is 0. So we get this. And since we care about factoring, it's not really wrong to leave it like this. But, well, actually, no, we're not there yet. Remember what we did was we multiplied by a fifth. That is, we divided top and bottom by 5. Right? Well, what I'm going to do is multiply top and bottom by 5. I want to get back to what we started with. Right? To get to this, I divided top and bottom by 5. That is, I multiplied by a fifth. So now I multiply top and bottom by 5. That doesn't change anything. Right? Now we are, let me get back to it. Now we are back where we started. Right here, I multiply top and bottom by a fifth, which is the same as dividing by 5. So in this slide, no, not this slide, I multiplied. And you can see we're back in the original problem. We get this is equal to this quotient, which we just rewrite this way. It don't look scary, I understand. It's not as bad as it looks, though. You just have to basically do the extra step of dividing and then multiplying. That's all we did. So we get it is a factor. 5x plus 3 is a factor. In fact, the quotient, if you calculated it, is this. And if we were to factor further, we would have to try and figure out we would have to factor this thing. I'm not doing that. So I want to focus on division for now. And this is just the process of basically what I did. I know there were some more calculations in there, but really this is what I did. If you're taking a polynomial here and dividing it by this, ax minus b, you basically are going to divide by a And then you apply synthetic division, and what you'll get is something like this, a quotient and remainder. Then you multiply by A to get this. That's all. That's really what we did. We divided by A, then we multiplied by A again to get back to what we started with. That's all. We'll do another example, don't worry. Okay, hold on, let me just pause the recording.